right, our next test. We're learning 2 additional tests. So for the quiz on Friday, you will have 5 tests. Yes. Oh, I'm sorry, Thursday. Quiz on Thursday. I was looking at the wrong column.
We have 5 tests and a quiz.
5 tests of convergence for the quiz on Thursday. Here is the 4th convergence test. The integral test. I bet it involves taking integrals. F is positive, continuous, and decreasing. Guess what? We have to make sure that those are true for the function in question. Which means I need to see proof that you checked positive, continuous, decreasing. And continuous. So positive is our function above the x-axis. Continuous. Do we have any breaks? Decreasing. Is it decreasing? Thank you. Derivative negative. Okay. So if our improper integral converges, then so does the infinite series. Same thing with divergent. If this diverges, then this is also going to diverge. They both do the same thing. Now, unlike the 2 tests for convergence that we learned Monday, Friday, we do not know what this converges to. We will just know, yes, it converges, no, it diverges. We don't know the value. Yes?
So it's similar to the term test, but better.
Well, the nth term test only tells us if something diverges. Therefore, there would not be a value. Here, it's going to tell us convergence versus divergence. Yes. Now, I will warn you, the integral test of all the tests will be the most work up front. So this is a test you want to avoid if you can. However, there are going to be instances where you cannot avoid it. Okay? I want to start out with one that you saw in your homework last night. Maybe you didn't recognize that this was geometric. Raise your hand if you did not recognize this as geometric. Okay. So, you don't recognize it's geometric. You're looking for some other way to figure it out. We have the integral test. Okay? If we use the integral test, then we're talking about the function e to the negative x. I need to see that you checked. Is this a positive function? And all that matters is after 1. After 1, is this above the x-axis?
How do you know how it works?
Do you not know what this looks like?
I know what it looks like, but how do I prove that I checked it if that's where it checked?
You write positive. Check mark.
Dang.
Okay?
You do that with project.
Continuous. Yes or no?
Yeah.
Okay, decreasing. This you have to prove to me, Grayson. How could you prove it to me?
First derivative.
The derivative is negative e to the negative x, which is always less than 0. So decreasing. So now what we can do is we can look at the improper integral from 1 to infinity of e to the negative x dx. Now we went through an improper integral the other day, right? Because I was kind of showing you something.
Yeah.
Okay. So remember, we changed that infinite limit to...
J.
I already wrote A, sorry. To A. And we take that limit towards infinity. Antiderivative of e to the negative x. Okay. Evaluated from 1 to j, so we have the limit as j approaches infinity of negative e to the negative j minus negative e to the negative 1. Towards infinity, what happens to negative e to the negative j?
0.
We get a value. This improper integral converges to 1 over e. So since the improper integral of e to the negative x dx converges, then our series also converges by the integral test. Was that more work than identifying it to be geometric?
Yes.
Yep. Yep, it was.
I don't know if there was more details about it, though.
What?
Not more work than the telescopic ones. If you thought that was good.
Okay. Speaking of telescopes, cool moon tomorrow
Yeah.
morning. What time do you have to wake up to see it?
Is that at like, it's like at its best, out of school time.
8 o'clock or like 7 o'clock?
7 something, so you'll be there.
Okay. It's a super blue lunar eclipse.
And also,
Okay.
it's great.
Yeah.
What do you have on your face?
Okay. Write this one down.
What was the name?
Yes.
For the current test, it's like more like a negative everything. So since that one
Okay. The limit of the sequence. The limit of the sequence e to the negative n, that would equal 0. Which is why we can go through all of this.
So it doesn't vanish. Wait.
We just don't know anything. Okay? Is that clear?
I meant that it doesn't like.
Okay. So the nth term test looks at the sequence only. So it takes the limit as it approaches infinity of the sequence. Well, the limit of that sequence is 0, which means the nth term test tells us nothing, and we had to use a different test to determine convergence. Okay? Same thing is going to be true here. If we look at the limit towards infinity of natural log of n over n, n gets bigger while natural log of n gets smaller. Well, no, they both get bigger, but n's going to get bigger faster.
Yeah.
Agreed.
Okay, so that limit is going to be
So
0. You could use L'Hopital's rule, 1 over n over 1, that goes to 0. Okay, yes.
So this test doesn't give us a value?
Nope.
What was the one?
Okay, the 1 over e represents the area under the curve from 1 to infinity.
Okay, so it represents the line, okay.
Yeah.
Okay.
Okay, this one, is it geometric?
No.
No. Is it going to be telescopic?
No.
Nope. So far right now, our only other test is the integral test. And I will tell you, if there is a natural log in your series, no.
Voodoo.
That,
Voodoo.
okay. When you see a natural log and a 1 over n together, that's like the perfect setup for yes, use substitution in an integral test. I'm just going to tell you that flat out. Okay. So let's check. If f of x is the natural log of x over x, is this positive?
Yep, check.
Yeah.
Is it continuous from 2 and above?
Yeah.
Okay, is it decreasing?
Yeah.
Well,
Yeah, because it's getting smaller. You said that. Smaller on top than on the bottom.
Yep, that's negative.
how do you know?
Negative sign. Oh, wait. I missed that one.
1 minus natural log of x, is that going to be negative?
Yep.
From after 2.
Yep.
After 2, right?
Yep. Yeah.
So 1 minus e to the y equals 2, and that one.
It's always going to be plus 0. But honestly, it's just not going to be. It's not going to be right.
It's really at e when it makes the switch. The natural log of e is 1, and so that's when the numerator would be 0. And after that, it is negative. That is good enough. I know e is 2.7, but from 3 on, if we're talking about like the sequence, it's decreasing, so that's fine.
So
Okay.
if I'm really guessing, then I'm close enough.
What? Right.
Does that mean technically
No. E is not even a part of our sequence because we have to have, whole numbers. All right, so now we're going to look at the integral from 2 to infinity of natural log of x over x dx. I'm going to use 8 this time. It's more comfortable. To take this antiderivative, we need to use what?
Voodoo.
Technically, when I have u du, my limits are not 2 to a, but I would prefer not to change the limits of integration and get all screwy, so I changed it back to x. Now, if you want to change your limits of integration here to natural log of 2 to the natural log of a, you go for it. Okay, but I decided to change them back. So now, we have the limit as a approaches infinity of 1/2 natural log of a squared minus 1/2 natural log of 2 squared. Natural log of a. Draw a picture for me in the air. Like this, right? So towards infinity. So this diverges. Okay. Since the integral from 2 to infinity of natural log of x dx diverges, then the series from 2 to infinity of natural log of n over n also diverges by the, oh, what?
This is about you, not me.
Integral test.
Oh, Siri.
Yeah, I mean, that's like
Yes.
the series
Oh,
from 2 to
okay. I was like,
This is a
Yeah.
bad one.
Hey Siri.
All right. I don't want you to write this one down. I want you to just sit back and watch me. How does that sound?
Shoot.
We love it.
Sounds like a little bit.
Thoughts about this one? What's the limit towards infinity of 1 over n cubed?
0.
0. And term test is out. Is this telescoping? No. Is this geometric?
No.
No. If we use the integral test, is it positive?
Yeah.
Is it continuous from 1 and above?
Yeah.
And is it decreasing?
Yes.
Yes. Because our derivative is negative. All right. Now, when we take the integral from 1 to infinity of 1 over x cubed dx, we have the limit as b approaches infinity of 1 to b of. What's our antiderivative? Yes. What is it? Negative 2 over x squared? What happens? Is it 2 over x squared?
I don't think it's
Okay, I was like, this isn't feeling right at all.
Everyone's looking at it and being like, there we go.
Okay, what happens with this limit?
In the second one, this is 1 over x cubed.
Yeah.
Now it makes actually, it's a
This converges. Are we in agreement?
Yeah.
This converges, our series converges. Okay, what if this was 1 over x to the 4th?
It would converge to 1/3.
Okay, what about 1 over x squared? Okay, are we in agreement that x squared, x cubed, x to the 4th, all of those, we'd have this pattern of convergence? What about 1 over x?
0.
0.
What? What's the antiderivative of 1 over x? The natural log. And the natural log towards infinity goes to infinity. Okay. Instead of having to do this every single time, we know there's a pattern. This is called a P series. 1 over n to the P. And instead of having to do the integral test every single time, we can just figure out that value of P and know, does it converge or diverge? Does anybody play the guitar?
Yeah.
You do.
The converse.
When P is 1, it's called the harmonic series.
Physics.
Actually,
What's wrong with harmonic?
I don't know. They were hard.
They weren't that hard.
That was my
They weren't
worst
even
one.
done at all.
You guys mess around with springs for like a week or now. Yeah, we can fix it all.
Water.
Okay, so here's your rule. The P series test.
To whom should I send your message?
I thought it said, he thought I said series text. I know, right? Okay. Okay, so the P series test. You look at the value of P. 1 over n squared, 1 over n cubed, 1 over n to the 4th. We decided those all did what? They all converge. If P is greater than 1, our series will converge. P series test. Done. Okay. What about if P equals 1? We talked about that. That would be the natural log case. P is less than 1.
Diverge.
You guess.
Because it's just you just say it's gonna be a whole number.
Well, if you had like 1 over x to the 1/2, that antiderivative would become x to the 1/2 times 2. That's going to diverge. Okay? You could do that with any fractional power under 1 in the denominator. So now, if you were to get a series, let me know when you're ready. No, you're good. I just don't want to like leave you behind. No child left behind.
Wasn't that
George, you know,
It's not. It's not. It's bad.
What?
Isn't that a program?
I wish they
Like way back in the
There's the policy that is very misleading.
no, long time ago.
Isaac, don't you just wish they would leave you behind sometimes?
Yeah. Makes us take standardized tests, right?
Very much.
All right. Now, if I give you this, the series from 1 to infinity of 1 over n squared, it is a P series. So, we know that this converges because P is greater than 1, P series test. Now, it's not always going to be straightforward. There are going to be times where you have to rewrite, kind of like you did way back when we were taking derivatives and antiderivatives in Calculus AB last year.
So,
Write this down.
do we just change
How would
this?
you?
Stop it!
This time it
Yep, diverges.
Yeah,
P
diverges.
series.
Is that a song?
Yeah,
What?
it's a good country song.
I don't think so.
Country?
Now, you can't just say P series diverges. You need to do what first?
Change it into 1/n.
N to the -1/2.
You need to write it as 1 over n to the 1/2, and then you can say diverges, because we have p is less than or equal to 1 for our P series test. Don't ya? Don't ya? All right, so I'm going to give you about 20-ish minutes to work on your book assignment, and then we'll do a short-ish activity to fill up the rest of our block time. We have 5 tests. At term test, you always have to determine if the limit is 0 or not, because if the limit is not 0, there is no sense of doing anything else. Geometric should be semi-obvious. Okay, does it look like an exponential function? Telescoping series, do you have 2 fractions that are being subtracted? P series now should be one that should stand out to you. And anything left over, you have the integral test to track.